In this lecture, we continue interrupts. In the last lecture, we have discussed interrupt, what happens inside the microprocessor when interrupt occurs, and also hardware circuit. Now here we will analyze the enabling and disabling of interrupts. Then why this enabling and disabling is required? Now during the program execution, the arrival of an interrupt request from external device cause the processor to suspend the execution of one program. Now, this is the main program. If any interrupt occurs in between, then it will suspend this program and it will jump to the ISR and it will execute the another program. And because the interrupts can arrive at any time, they may alter the sequence of events and that is not acceptable for sometimes. No, that's why this controlling of interrupts is very essential. So that's why it is needed enabling and disabling. Then how can we do that? So there are three methods are there. One is enabling and disabling by writing the instructions in the ISR program. Enabling and disabling instructions. These are the instructions we are writing in the ISR program. Now, if this is a main program and when it is jumping to the ISR program, the first instruction is nothing but a interrupt disabling instruction. And after that, instructions are written here related to that particular ISR. And the last but one is again interrupt enable instruction, and the last one is written instruction, I written or written instruction. Now, when this ISR program is being executed, that time the interrupt itself, by writing this instruction, the interrupt will be disabled. Means in between, if any IO devices are requesting the microprocessor for service, then these interrupts are not accepted by the microprocessor because the interrupt disable instruction is written here. Now, after again, whenever while again it is coming back to the ISR to the main program, that time again interrupt is enabled so that if any interrupts, any IO devices are asking for the interrupt service, then the microprocessor will accept that interrupt. Like this, if within the ISR by writing the interrupt disable and interrupt enable instruction, then we can control the interrupts. And the second one is, now already you know that this is the main program. If the interrupt occurs, then before going to execute the ISR, now in the stack, values of PC value is stored onto the stack. This is considered as a stack. PC value is stored onto the stack. PC value is nothing but what? Next executable instruction address. This address will be stored onto the stack. And also status register. Status register is nothing but which is having the conditional flags and control flags. So it will show the what is the status of the microprocessor after executing one instruction. Now in this, one of the bit or one of the flag is IE, interrupt enable flag or interrupt enable bit. Now by making this interrupt enable bit is equal to 1, the microprocessor accepts the interrupt, nothing but enabling the interrupt. If this flag, if we make it as a 0, then it is nothing but a interrupt disable. So microprocessor will not accept any interrupts if the IE bit is equal to 0. Now, before copying this status registers content onto the stack, automatically microprocessor disables the IE. Thereby, now after copying that, it will execute the ISR. Now, in between any interrupt generates, then it will not accept. Why? Because the interrupt enable flag is 0. So thereby, the interrupt is disabled. That's why microprocessor will not accept any interrupt. Now, after executing this ISR, when it is after executing the return, again it will go back to the stack and it will copy the PC onto the address onto the PC, and also status register content onto the status register. While copying this content onto the status register, again it will make the IE is equal to 1. Thereby, now if any IO devices are requesting for the service, then microprocessor will accept the interrupt. Now, like this, by enabling and disabling, these are the two methods. And the third one is here. Already we have seen in a hardware circuit. So we have one interrupt request line. Now this line is handled by the interrupt handling circuit. This is the interrupt handling circuit. Now this circuit will be triggered. This circuit will be triggered or enabled by the edge triggers only. This circuit will be activated by the edge trigger. Now if you take, this is a clock, and from going to low to high, this is called one edge. From high to low, this is also one more edge. Now this is called as a level. This is a level trigger, this is edge trigger, and this is also edge trigger. Now coming to here, leading edge trigger means what? When it is going from low to high is called the leading edge trigger or positive level trigger. High to low is negative edge trigger or falling edge trigger. Now any interrupts are generated when the leading edge trigger is taking place. Any interrupts are generated, that time only it will accept those interrupts. However, the interrupt is enabled for the longer time. Now if you see, this is the level trigger level. In this time, now if any devices are sending the interrupt request, those will not accepted by the microprocessor. Why? Because this circuit will be um, enabled only, triggered only when the leading edge trigger is taking place. Now at the time only processor accept one interrupt. If multiple interrupts are also generated, then also microprocessor will take only, accept only one interrupt. Like that, here without enabling and disabling, at a time microprocessor is accepting only one interrupt. Now in the previous also, by enabling and disabling, what the processor is doing, it is accepting only one interrupt at a time. During the execution of ISR, another IO device should not interrupt the microprocessor. This is the concept of enabling and disabling the microprocessor. Sorry, enabling and disabling the interrupts.